September 1st, 2014, 6:32 in the evening, UTC. DigiByte mines block 145,000, and it's a script block, like every one of the 145,000 blocks before it. 41 seconds later, the next block shows up, and it's SHA-256. First block in DigiByte's history that wasn't script. And then something happens that honestly looks like a malfunction. Qubit steps in and takes the next 20 blocks. Not 20 over the next hour, 20 blocks in 16 seconds. One algorithm just ran away with the whole chain, and I pulled those blocks myself, one at a time, off public chain data. That really happened. So was the 5 algorithm design broken on day one? No, that was the design working, out loud, in public. And what happened in those 16 seconds is the thing almost everybody gets wrong about DigiByte. So this video exists because somebody asked for it. On the DigiByte 101, Trinity left a comment, and it's on screen right now. The ask was simple, the 5 algorithm mining design. And then this line, which is really why we're here. I have had it a long time. That's not somebody who needs DigiByte explained from scratch. That's somebody who's held it for years and wants to know how the thing actually works. And Trinity is also the person who keeps showing up in our comments, solving other viewers' problems, unprompted. So when a request comes from there, it moves up the list. And there's a second half to that comment I'll be straight about. Trinity also figured privacy for institutions would eventually come into play. DigiByte isn't a privacy chain, and I won't pretend it is. It's a security chain, and today we're looking at the machinery that makes that claim mean something. Now here's the myth. Search around for how DigiByte's 5 algorithms work, and you'll hear some version of, they rotate, they take turns, round robin, one after another. It's clean, it's tidy, and it is not what the code does. I went looking for the rotation. There isn't one. When a DigiByte node accepts a block, it checks whether that algorithm is allowed at all. It never asks which algorithm mined the block before. Nothing forbids the same algorithm mining 2, 5, 20 blocks in a row. You don't have to take my word for it. Look at the live block feed on screen. Qubit, then qubit again. Odo, then Odo again. Right there, in the last few minutes of real chain history. So if nothing is taking turns, why does it come out so even? Okay, here's the actual mechanism, and it's genuinely elegant. Every one of the 5 algorithms carries its own separate difficulty, its own. And DigiByte adjusts that difficulty by asking one question. How is this algorithm doing against its fair share? Fair share is 1 block in 5. So if an algorithm is running ahead of that, the code makes it 4% harder for every block it's ahead. And if it's fallen behind, 4% easier for every block of shortfall. That's the whole thing. So go back to those 20 qubit blocks. Every one of them made qubit 4% harder than the block before. 20 deep, and qubit is brutally expensive, while the other 4 have been getting 4% cheaper, over and over, looking more and more attractive. The chain isn't policing anybody. It's quietly repricing 5 doors until the crowd redistributes itself. So 20% isn't a rule, it's an equilibrium. It's where the money says you should be. Does it actually work? I measured it. I pulled 300 consecutive DigiByte blocks off the live chain this afternoon and decoded every one. All 5 landed between about 19.5% and 20.5%. No coordination, no referee, and they came out within a percent of each other. And one more number, the network targets a block every 15 seconds. 5 algorithms, 15 seconds. So each individual algorithm is really aiming for 1 block every 75 seconds. And when you look at the live per algorithm block times, they're all sitting right around 1:10, 1:20. Exactly where the arithmetic says they should be. Right, so who are the 5? 2 of them you already know, because they're borrowed from the biggest chains in the space. SHA-256 is Bitcoins, mined by those same industrial warehouses full of chips, and Script is Litecoins. Then there's Skein, which came out of the SHA-3 competition, and Qubit, which is the lightweight one, easier on power. And then there's AutoCrypt, which is DigiByte's own. And AutoCrypt is the strange and wonderful one, because AutoCrypt rewrites itself every 10 days. The algorithm mutates into a different version of itself on a timer. Designing a custom chip takes months, so by the time your ASIC comes off the line, the thing it was built for doesn't exist anymore. Now here's the part I really want to give DigiByte credit for, because it's a class act and almost nobody mentions it. DigiByte did not invent multi-algorithm mining. Myriad Coin did. Myriad Coin shipped the first 5-algorithm proof-of-work chain in February 2014, 6 months before DigiByte's fork, using the same 5 algorithms. And DigiByte's response was to say thank you in the wallet. There's a line in DigiByte's own About box that reads, "A special thanks to the Myriad Coin developers for their help with the multi-algo update." I love that. In a space that is not famous for crediting its sources, they wrote it into the software. And one for your calendar. AutoCrypt runs on that 10-day clock, and the current version came in on the 26th of July. So the next rewrite lands on the 5th of August, 4 days from now. So on the last DigiByte video, a viewer called InnerFire left a correction, and I want to read it to you because they were right, and being right sharpened this whole video. They said, DigiShield isn't just a real-time difficulty adjustment for the blockchain as a whole. It's a real-time difficulty for each individual mining algorithm. And the 5 of them together, each with its own real-time adjustment, that's called MultiShield. Yeah, that's correct. And I went and checked it in the source, because that's the deal. I don't repeat things, I go look. What's on screen is DigiByte's actual difficulty code. There's a comment that says, Global Retarget, handling the chain's overall block rate. And directly underneath it, a second comment that says, Per algo retarget. That's the 4% correction. 2 terms, stacked. So the precise version is this. Each algorithm gets its own difficulty, and that difficulty responds both to how the whole network is doing and to how that algorithm is doing against its fair share. Not 5 sealed off silos, 5 dials, each with a hand on it. And when the code looks for something to compare against, it doesn't grab the last block on the chain. It walks backwards to the last block mined by that same algorithm. Now, InnerFire had one small detail off, and I mention it only because precision is the point of this channel. They said the fix that shut the retired 6th algorithm out came in version 926.4. It was 926.2. Easiest slip in the world, because the very next release reprints that whole fix section in its own notes. Everything else, dead on. All right, now the part where I owe you the other side, because a design this clever still has a bill attached. Look at the live hash rate on screen. SHA-256 is running about 42 petahash. Every other algorithm on DigiByte is measured in terahash, thousands of times smaller. So SHA-256 is somewhere around 98% of all the raw computing power pointed at DigiByte, and it earns about 1/5 of the blocks. Sit with that, because it's the best argument for the whole design. Raw power and actual influence have been deliberately unhooked from each other. You can bring an ocean of hash rate to one algorithm, and the difficulty math will just keep making that door more expensive until you're paying a fortune for the same 20% of blocks. Now the honest half, and there's a real, published criticism here that people have made for years. You split your defenses 5 ways, and if one algorithm is shared with a much bigger chain, that leg is comparatively cheap to overwhelm. I'm not going to wave that away. It's a fair point. The flip side is that Skein, Qubit, and AutoCrypt are effectively DigiByte's own. Nobody's renting those. So the cheap door and the expensive door are different doors. And then this year, the design got tested. Twice. The first you might remember from the last video, so I'll keep it short. A 6th algorithm DigiByte retired in 2019 briefly got mined again because the check enforcing that retirement had gone missing during a big code merge. They locked it out at a fixed block height, and when I measured 300 blocks this afternoon, it came back at exactly 0. The second test is the one nobody's covered. When DigiByte switched on its DigiDollar upgrade, the signaling bit it used collided with scratch space that SHA-256 mining chips rely on, and pool operators started losing roughly half their shares. Real cost, real people. And the founder's response is on the public record. I sincerely apologize for the trouble. We should have used a different bit, but we can't change it now. No spin. But the sentence that matters most here is the next one. This issue only affects SHA-256 and not DigiByte's other 4 mining algorithms. That is the design doing its job. A serious mining bug landed on 1 leg out of 5, and the other 4 just kept going. So what does 5 algorithms actually buy you? Not a rotation, not a marketing line. It buys a chain where influence is priced separately from power, where a bad day on one algorithm is a bad day on 1/5 of the chain, and where the correction is automatic and constant, 4% at a time, every block. 12 years on, and I measured it holding to within a percent this afternoon. And Trinity, one more for you, because you mentioned liking that the supply is limited, and I'd rather answer that mechanically. DigiByte doesn't have. There's no 4-year cliff. The reward decays a little over 1% every month continuously, and the code names the last block that will ever pay one. Block 41,668,798. Then miners live on fees. That's a schedule you can go read. So here's your action item, and it's dated, so you can check it yourself. AutoCrypt rewrites itself on that 10-day clock, and the next rewrite is the 5th of August. Pull up DigiByte's algorithm dashboard before and after, and watch a live blockchain change one of its own mining algorithms while you're looking at it. Almost nothing in this space lets you watch the machinery move like that. And if you want to dig into this with people who care about mechanics, come join us. That's our Discord on screen, the Motion Room. It's early, which means there's room for it to become yours. Bring a source, bring a question, tell me I got something wrong. Some of the best material in this video came from exactly that. And if you'd rather it land in your inbox than chase it, there's a newsletter. It's on screen, and it is one email every Friday. That's it, one a week. Every number traced to a primary source, plus an honest list of what I cut because it didn't hold up. Links in the description. If this was useful, subscribing genuinely helps. This channel runs on precision, not volume, and the requests you leave in the comments are what turn into videos. This one did. Thank you, Trinity, for asking, and thank you, InnerFire, for the correction that made it sharper. I'm going to go watch an algorithm rewrite itself on Wednesday. Come with me.